Welcome, everyone. Good morning, good afternoon. We'll just wait for everyone to join right now. Welcome. We're just giving a few minutes for everyone to join. Right. I think we'll start with 3 minutes past the hours. So welcome to all EPI-WIN webinar guests today. Good afternoon, good morning, good evening, and a particularly a strong welcome, if you like, for those of you joining away from far away, or from those of you for whom it's really late or very early. We really appreciate your presence here. Today, we have a very exciting webinar on vaccines for seasonal and avian influenza, hosted by WHO EPI-WIN. For those of you who are new to EPI-WIN, this is the WHO Information Network for Epidemics for Science and Knowledge Translation in Health Emergencies. With these EPI-WIN webinars, and we also have an associated EPI-WIN digest of slide sets which summarize the key messages from these webinars, our goal is to translate science in accessible, understandable, and relevant ways for evidence-informed actions and decisions, both for the public and for decision makers in health emergency preparedness and response. We have a really exciting list of speakers today. Dr. Wenqing Zhang, who needs no introduction in the influenza world. She's the head of the Global Influenza Program, will be welcoming you shortly, followed by Dr. Nicola Lewis, who will talk about seasonal influenza vaccines. She's the director of the Worldwide Influenza Center, which is a WHO collaborating center for reference and research on influenza in the Francis Crick Institute. And Dr. Richard Webby will speak after that. He's the director of the WHO Collaborating Center for Studies on Ecology of Influenza in Animals and Birds from St. Jude's Hospital. We also have something for you. We'd love to know what you feel, and we have a short quiz for you as well, which was coming up soon. It's a surprise. But before that, before I hand over to Wenqing, some housekeeping. This webinar, as you know, those of you who are regular, is being live streamed on EPI-WIN YouTube channel. It's also being recorded, and afterwards the recording will be available from our website, and the address for that will appear in the chat. Interpretation is available today with our wonderful interpreters from Transperfect on Arabic, French, Portuguese, and Spanish. Please go to the interpretation globe icon in Zoom to access and select the language. We also have AI-enabled interpretation, since our Our goal is to reach as many people as possible. The AI interpretation is in Chinese Mandarin, Hindi, Russian, and Bengali, the largest, most widely spoken languages. We invite you to post your name, location, and organization in the chat box, and we would love to hear where you're coming from. And finally, if you have any questions, please put it in the Q&A box and not the chat box, because sometimes your questions get lost in the chat. It's much easier for us to keep track of them in the Q&A box. We will have a Q&A session at the end. Also, for those of you whose questions are not answered, we will try and have a summary response later on. Now, without any further ado, over to Wenqing Zhang. Wenqing, the floor is yours.
Thank you very much, Supriya. I hope you can hear me well. Good.
Yes.
Hello, everybody. Welcome to this webinar on influenza. And today, we are going to focus on vaccines. Vaccines for seasonal influenza and vaccines for avian influenza. Winter is upcoming in the Northern Hemisphere, so is flu season. Every year, an estimated of 1 billion people are infected with influenza, and of those, 3 to 5 million people had severe infection or severe diseases. And every year, we have up to 650,000 influenza-related respiratory deaths globally. To prevent infection and especially severe outcomes caused by influenza, vaccination is the most effective way. Influenza disease is caused by influenza viruses, which are naturally constantly evolving. So there is an increasing risk that the circulating viruses escape the immunity induced by the vaccines. For this reason, the vaccines contained or the viruses contained in the vaccines need to be updated. WHO holds twice a year consultations with experts from the WHO Global Influenza Surveillance and Response System, issues recommendations of composition of flu vaccines for the upcoming influenza season. The last one took place last week, indeed, and WHO issued the recommendation last Friday on 29th September. Influenza is among the top of global public health threats, not only because it kills hundreds of thousands of people every year, but also it causes pandemics. We all know very well the 1918 pandemic, also called Spanish flu, is catastrophic, which killed about 50 million people. Some estimates even go up to 100 million. In 2009, we had a pandemic in a mild format, similar to severe seasonal influenza, which killed up to 575,000 people in an estimate. While in 2020, we had a pandemic caused by SARS-CoV-2 viruses, but we know that based on the knowledge of understanding, a next influenza pandemic certainly is a certainty. So in the modern digital era nowadays, we all know that the highly pathogenic avian influenza H5N1 spillover in mammals. It sends off strong signals of flu pandemic alert, reminding the world that the threat of any influenza pandemic is real. Last week, in the WHO's consultation for influenza vaccine composition, another objective achieved is a thorough review of the epidemiological situation, the virus characterization of avian influenza and other animal influenza, and subsequent selection of viruses for the development of candidate vaccine virus for pandemic preparedness purposes. All this work mentioned is based on the year-round surveillance by a global system called Global Influenza Surveillance and Response GISRES system. Last year, GISRES celebrated its 70th anniversary, And now we are advancing this system towards its 100 years. Beyond the influenza, Gistrus has been leveraged to other respiratory viruses. For the RSV since 2015, and also SARS-CoV-2 since March 2020. The work of integrating a range of respiratory virus with epidemic and pandemic potential into the expanded Gistrus is ongoing to prepare the world for a safer and more secure future. So today, in this webinar, as introduced by Superior, we have two experts who were in the advisory committee last week in the WHO consultation, Dr. Nicola Lewis and Dr. Richard Webby. Before we proceed the agenda, I was advised by my colleagues that we have an interesting session here to have a Q&A from the audience, an interactive session. And for this one, Superior will moderate. Superior, you have an interesting session prepared for now?
Yes, thank you, Wenqing. Thank you, Wenqing. We will just put on, just in a few minutes. I hope you see a few questions. Please choose. Let's see what you think about influenza. We have two questions. Please select the questions that you think is correct. The first is influenza is caused by either a virus, bacteria, fungus, chemical, or other. You have a multiple choice there, anything you can choose. And then there's a yes/no question. Influenza can be treated by antibiotic. Oh, great. Can you see the results? Excellent. Oh, so we have a group here that really knows about influenza. Fantastic. Thank you very much. So 99% of you have correctly chosen influenza is caused by a virus. And can it be treated by an antibiotic? No, that's false. That's 96% of you said that. Thank you so much. Now over to Nicola Lewis.
Thank you, Supriya. And firstly, good morning, good afternoon, good evening from wherever you are dialing into this webinar. It's a great pleasure to be here today. I'm going to talk first about the viruses that will be included in influenza vaccines for the next season, and also a little about how this is decided, the pieces of information we use when we're thinking about the recommendations that we make. I'm actually going to thank people first, because as Wenqing mentioned, the information that we use to make the vaccine decision comes from the Gistrus network. And Gistrus celebrated its 70th anniversary last year. But the base for Gistrus is really the tireless efforts of the WHO National Influenza Centres around the world, who collaborate together as part of the network, who contribute and share the clinical specimens and virus isolates with the WHO collaborating centres. And without their constant efforts, we would not be able to consider making recommendation for the vaccines. So this is a thanks to all colleagues in member states around the world that contribute to the Gistrus network. And I'm presenting the data on behalf of them. I also should thank my colleagues in HQ, colleagues in the WHO regional offices, ECDC, the University of Cambridge, and also modelling groups in Germany, the United States, and Switzerland. I'm going to start by explaining a little bit about how we consider the data for the vaccine recommendation. We use epidemiological data, genetic data, and antigenic data. And as I said, these pieces of information are generated all the year round through the surveillance conducted by Gistrus. Part of the network are the WHO collaborating centres, the national influenza centres, the essential regulatory laboratories, and also, as Richard will talk about, the WHO H5 reference laboratories. We've just finished the consultation for the Southern Hemisphere vaccine composition recommendation, and this was something that we undertook last week. It was co-chaired by Dr. David Wentworth and myself, and you can see a picture in the bottom corner of us at work during the consultation. I'm going to show you some of the pieces of information that we have on influenza from the recent years. This is the number of specimens processed by GISRIS by week from 2020 through to 2023. You can see this yellow line is the 2022 season, and it continues as 2023 influenza circulation as the red line. The number of specimens processed by GISRIS in 2022 and 2023 are very similar. Whoop. Don't quite know what happened there. One moment. I hope you can still see my screen. Apologies. So
actually not, Nicola. It's dark, at least on my screen here.
Ah, okay.
Now it's back.
Ah, excellent. Good. Thank you for that, Wenqing. Can you now see in full screen? Excellent. Thank you for the thumbs up. So this is the geographic distribution of the countries, areas and territories which shared viruses with the collaborating centres. And you can see it is truly a global effort. We saw circulation of influenza viruses in the Northern Hemisphere, shown on the left-hand side, and in the Southern Hemisphere from February through to the end of August. It was the end of the Northern Hemisphere season, predominated by influenza B viruses, and then the Southern Hemisphere season started, and they had a proportion of influenza A, H1N1 viruses, and also B lineage viruses. When we look at the influenza activity from February through to the end of August, you can see that the proportion of H3, H1 and B Victoria lineage viruses differed by the country or region of the world in which you are looking. If we look at the Southern Hemisphere, we saw that in some parts of perhaps Africa, we saw most viruses being H3 viruses, whereas in some parts of Central and South America, we saw a greater proportion of A, H1 viruses and B Victoria viruses. I'm going to show you some of the information from the AH1N1 PDM09 recent evolution. We have an expanding genetic set of viruses that are PDM-H1N1 viruses currently. We put them into genetic groups, and indeed most of the genetic groups that have been circulating recently contain viruses from the 5A2A clade and the 5A2A1 clade. And these are shown on these maps as the two bottom pink colours that you can see on the left-hand side. In the phylogeny on the left-hand side of the page, you can also see again these 5A2A and 5A2A1 viruses marked. And if you look at the tick marks in the middle panels for 2023, they indicate where geographically these different genetic groups of viruses were circulating. For example, we saw many 5A2A viruses circulating in South America. You can see that from the lighter blue colour, whereas we saw more 5A2A1 viruses circulating recently in North America and indeed in Europe. We also antigenically characterize these viruses and compare their properties with the recognition by the influenza vaccine strains. On the right-hand side of this slide, you can see an antigenic map. We make antigenic maps using hemagglutination inhibition assay data, and we characterize the viruses relative to the immune system recognition of ferret antisera raised to specific strains of virus. Then we use a process called antigenic cartography to make antigenic maps that show us how similar different viruses are to the vaccine strain. And you can see for this reporting period, viruses that have been circulating from the 5A2A and the 5A2A1 groups are shown as pink and purple dots in this map. You can also see that the big circles are representatives of the A-Sydney 521 cell and egg vaccine recommendation components. And you can also see in purple the A-Victoria 4897 2022 and A-Wisconsin 67 2022 vaccine components that were recommended for the Northern Hemisphere. We also use human serology. When we used the ferret antisera to characterize the antigenic properties of the H1N1 viruses, we noted that they all seemed very similar, and there was good recognition by the vaccine serum for the currently circulating strains. However, when we used human serological panels to look at these current viruses, and these are people who have been vaccinated with the A-Sydney 5 2021 cell component, we found that their antisera didn't recognize the 5A2A1 viruses as well. So for the H1 viruses, we saw a loss of recognition by the potential loss of recognition by the vaccine strain for currently circulating strains. Now I'm going to talk a bit about the H3N2 viruses for this particular season. Like the H1 viruses, we see many genetic groups of H3 viruses circulating globally, and we also see that the proportion of different genetic groups circulating depends on where they're circulating. The major genetic groups in this reporting period were the 2A3A1s, shown in this blue colour, the 2Bs, shown in the yellow colour, and the 2A1Bs, shown in the green colour. And you can see different proportions of these viruses circulating in Europe and then in other geographic regions. So we consider all these pieces of information and we compare the sequences of the viruses to the vaccine strains, as is shown in this phylogenetic tree. And this time we were comparing the sequences with the A-Darwin 6 2021 vaccine component. And we saw during this whole year a change in proportion of these viruses, whereas from February through to the present, we saw the proportion of 2A3A1 viruses increase markedly, as can be seen on the right-hand side of this slide. Again, we also use hemagglutination inhibition assay data to compare the antigenic properties of these viruses. And you can see here that we saw good recognition for the 2A3A1 viruses by the antisera raised against this particular genetic group, whereas for the 2B viruses, we saw some loss of recognition. And indeed, that was true for the 2A1B viruses as well. We also use antigenic cartography to look at the antigenic properties of the H3 viruses. And here you can see that these green strains from the 2A3A1 group are very antigenically similar to each other, but a little bit different from some of the vaccines that have been used in previous seasons. We also look at the properties, the structural properties of the virus. And these are some protein structures of the hemagglutinin protein, which we know is the primary target of the immune response. And you can see that there are amino acid substitution changes between the A-Darwin 6 2022 vaccine strain and a representative from the recent 2A3A1 vaccine genetic group. Again, we also use human serology. And here we found that there was some heterogeneous or different recognition by the immune system for currently circulating strains, which perhaps indicates that there's antigenic drift of these viruses and the potential to need to update the recommendation. We also have influenza B viruses circulating, and these indeed have continued to circulate from February through to September. But first, I'd like to take you back in time. This is the global circulation of influenza B viruses since late 2018. And what we see with the green curve is viruses that have circulated from the B Victoria lineage. And then we see from the blue line the viruses circulating from the B Yamagata lineage. And then we also see in the orange line viruses where the B lineage has not been determined. So the highlight of this slide is that we used to see co-circulation, or we used to see both lineages circulating. But since 2020, as represented by this blue line here, along basically the x-axis, we have had no detections of B viruses from the Yamagata lineage. So what I'm going to share with you now are the information for the B lineages, but we will be focusing on the B Victoria lineage because that's the lineage that we have detected recently. Again, we use the sequences to compare the properties, the genetic properties of the viruses relative to the vaccine strain. You can see that we continue to see genetic diversification within the B Victoria lineage. But when you look at the geographic spread, these have really been spreading and circulating at a global level, both from September through to January, and indeed more recently. Again, all from the B Victoria lineage. When we look at the antigenic properties of the B Victoria viruses, we can see that when we compare them with the current vaccine recommendation components, the B Austria cell component and the B Austria egg-like component, we see very, very good recognition for the currently circulating strains by these particular vaccine strains. So we can really see that at the moment, there is good recognition. If people were to be vaccinated with these strains, it is likely that the vaccine would be effective. Again, we use antigenic cartography, and you can see here what we have here is an anti-serum circle interpolated over the map. And you can see that this gives us an indication of where immunity might be lost. If all the strains and the circles fall within this large anti-serum circle, then we think the vaccine will provide good protection against currently circulating strains. And indeed, we saw evidence for good protection, whether we considered data from the collaborating centre in London or indeed from the collaborating centre in Melbourne. Again, we use post-vaccination serum derived from humans that have been vaccinated with the B Austria component. And you can see from this heat map that when it's blue, it means that these panels, this human serology is recognizing currently circulating strains very well. And then on the right-hand side, you see an older and distinct kind of genetic group. And you can see there that these viruses are not so well recognized by the anti-serum raised against the B Victoria cell component. I mentioned the B Yamagata lineage viruses. And as I said, we've had no confirmed detections of circulating B Yamagata lineage viruses after 2020. In fact, GISRIS actually collected over 15,000, nearly 16,000 samples just between the 1st of February and the 30th of August. No B Yamagata lineage viruses were confirmed. Some of the 15 that were identified initially as B Yamagata, 13 were confirmed to be B Victoria, or were negative indeed for influenza B virus, and 2 were not available for confirmation. So finally, I come on to the recommendation for the 2024 Southern Hemisphere influenza season. So this is the recommendation based on the data that we were analysing last week. And indeed, we made recommendation to update the H1N1 component to the recommendation, in line with the recommendation for the Northern Hemisphere, and update the H3N2 component to an A Thailand 822-like virus or an A Massachusetts 1822-like virus. I also note here that we have made recommendation as a committee of experts that it is our opinion that inclusion of the B Yamagata lineage antigen is now no longer warranted, and we should be making every effort to exclude this component as soon as possible. I provide here some links to the candidate vaccine viruses and publications, should you wish to take a look at these in more detail. And indeed, there's the zoonotic influenza summary reports as well, which Richard will speak more about shortly. Thank you very much for your attention, and I'd be delighted to take any questions.
Thank you very much, Nicola. So please, if you have questions at the moment, you can post your questions on the Q&A, and we'll come back to the Q&A at the very end of this session after the presentation from Dr. Richard Webby, who will present on the avian influenza, on the animal influenza, zoonotic influenza front. So again, we have an exercise here now by Supriya. Another quick Q&A.
Thanks, Wenqing. So all of you were fantastic in the previous questions. Obviously, we have a hardcore influenza group here. Our audience varies widely, so it's great to know that so many people with good knowledge of influenza is already here. So this time, the questions are probably slightly harder, just slightly. There you go. 2 questions. Animal influenza infects only animals, not humans. True or false? And the second is, candidate vaccine viruses for zoonotic influenza are selected to save time in the case where a vaccine may need to be developed. True or false? For zoonotic influenza vaccines, save time in the case where a vaccine may need to be developed. There's one word that's missing there. So. Please vote. We'll just put the results out in just a second. Right, slightly greater variation this time. Animal influenza infects only animals and not humans. Well, 94% of you said it's not true. And that's the right answer. And candidate vaccine viruses for zoonotic influenza vaccines are selected to save time in the case where a vaccine may need to be developed. True, 78%. Great. And false, 22%. You are right, of course, all of you who've chosen the majority of the answers. Great. So now you learn a little bit more about candidate vaccine viruses for zoonotic influenza vaccines. Over to you, Wenqing, and to Dr. Richard Webby.
Yeah, at the moment, let's move directly to Dr. Richard Webby's presentation on zoonotic avian influenza. Richard?
Thank you all, and good morning, good afternoon, and good evening. Okay, so hopefully you can see that. So what I'm going to very briefly discuss is, as you've just heard, the deliberations that we had last week, but specifically looking at these viruses that are circulating in other animal populations, so particularly the birds and swine of the world. And as you just heard from the quiz, the reasons we do this is that these viruses are going to be the source of the next influenza pandemic. And should one of these start to spread in humans, we would like to respond with making a vaccine. And that process of making a vaccine, as we know, can take 5 to 6 months. The first 5 to 6 weeks of that are spent making these candidate vaccine viruses that can be delivered to the vaccine manufacturers. And so the idea behind what we do here is, at these meetings, we look at what's going on in the animal sphere. If we see viruses that are of particular concern, we will go ahead and make these candidate viruses just in case they're needed. And therefore, if one of them does start to take off and circulate amongst humans, we're 6 weeks ahead of the game, and we can immediately send some of these candidate vaccine viruses to manufacturers. And so that's sort of summarized in here, that the viruses that we just heard Dr. Lewis talk about were viruses that circulate primarily within, well, almost exclusively within humans. So they're maintained by human-to-human transmission. The viruses I'm going to talk about are at this other sphere. So they are within these non-human animal populations. They circulate here, and every now and again, some of them will jump over, cause a zoonotic transmission to 1, maybe 2 humans, and most of those stop there. When we have a pandemic, of course, those viruses then start to spread human to human. So the viruses that I'm going to mostly talk about are viruses that were detected in the past 5 or 6 months that have made this sort of one leap from these animal populations into 1 or 2 humans. And that's where we spend most of our time during these deliberations, looking at viruses that have done that. The information that we use, I'm not going to go through this in any detail because Nicola just did, but these are the information streams that go into making the recommendations for the seasonal vaccine strains. We use essentially the same process for these zoonotic strains as well, with a little bit of difference. Clearly, we're talking about viruses that circulate within animals. So we bring in a lot of additional collaborators into these discussions, including the WHO H5 reference laboratories, including laboratories from the animal sector, particularly the OFFLU group, which is an FAO expert group of individuals on influenza who come to these deliberations as well. Typically, although there are also a little less data on some of these viruses than the seasonal counterparts. But the bottom line is the same type of process is used. We look at what viruses are out there, what their genetic makeup is, and what their antigenic makeup is. And so I'm going to run through, just as Dr. Lewis did, go through what we actually talked about last week. So here is just a slide showing the number of zoonotic cases. Again, these are viruses that have gone from animals into humans, but haven't gone any further than that. So each of these, number of cases on this axis, the time across the bottom, each of the different colors represents a different virus that's circling in the animal populations. There is a huge diversity of different influenza viruses circulating in some of these animal populations. It's only a small percentage of those that we actually see making this jump into humans, and they're represented by these different bars here. Sorry, it's covered up on my end. These are the different subtypes of viruses that we detected, of animal influenza viruses that we detected in humans in the past 6 months. And we'll talk about some of these now in a little bit more detail, particularly in the context of, do we need to update our arsenal of candidate vaccine viruses? So the big one that we spend most of our time discussing was the H5 viruses. And for reasons I think most of us are aware, these viruses have spread on a near global scale in the past couple of years. So this is a map from OFFLU. Each of these dots represents a detection or an outbreak in animal populations, so primarily in birds, the odd wild mammal as well. This sort of number and alphabet soup over here describes the genetic clades of viruses that were detected in this period. The big one has been this 2344B, and this viruses belonging to this particular genetic group are responsible for most of the dots that you see on this map. So it's really all of the dots in the Americas, most of the dots in Europe and Africa. There's a little bit more diversity across parts of Southern and Southeast Asia. But again, these 2344B viruses have been the ones that have been causing most of the problems over the past couple of years. We look at actually what's spread to human. Again, the majority of these have been the 2344B viruses. A couple of these, a different clade in Cambodia in February of this year. All of these individuals, with the exception of one from Chile where it was unknown, are people that had very, very close exposure to infected poultry. So poultry to human infection or detection. These people, these 4 cases from the UK are a good example of that. These were individuals that actually involved in depopulating an infected poultry flock. It's still some uncertainty about whether they were actually truly infected or just because they were in an environment that was so heavily contaminated, it looked like they'd been infected. And so you can see the age range here, mostly in adults or heading towards the more elderly adults. And here's a total number of cumulative cases we've had since early 2000s with viruses from the H5 lineage. The good news from a candidate vaccine virus point of view, when we looked at these viruses circulating in animal populations, particularly those related with the human cases, we found that the candidate vaccine viruses that we've already produced still reacted very, very well with the current crop of H5 viruses. So we made no recommendations to update our list of CVVs for H5, despite the fact that there's still very, very widespread circulation of these viruses in animals, mostly birds, with very sporadic spillover into humans and other mammals. If we look at the other virus, this is perhaps the virus that H5 aside is the most often found subtype of influenza in poultry populations around the world, the H9N2 viruses. During this period, we saw a lot of activity of the H9N2s, again, in poultry populations in many regions of the world. In China, there were 5 reported human cases from these H9N2 viruses, again in poultry exposed people, so people with very, very close contact with infected birds. And as you can see here with the H9, and this is a trend we typically see, it tends to be the younger individuals that are infected with H9. You can see here the disease was always mild. Again, H9N2 typically causes more mild disease as a whole than H5 can. And so here's some of the actual data we looked at with these viruses. And again, remembering these are our current vaccine viruses, candidate vaccine viruses across the top. The numbers in bold here are the homologous titers of anti-serum raised to those. As you go down the list here, as you get smaller numbers at the bottom here, that means that these vaccine viruses don't react as well with the currently circulating viruses. And I've circled this group here because it's the group of H9N2 viruses that have been circulating in mainland China for a few years now, causing human infections both in 2022 and the 2023 viruses belong to this group as well. And you can see the hemagglutination inhibition titers to these viruses were lower than the homologous titers for each of the vaccine strains that we do have. Again, that's a signal to us that we need to go ahead and update viruses for this group, and we did. And so we recommended one new H9N2 viruses that represents the current crop of H9N2 viruses in China. This data shared by the WHO Collaborating Center in Beijing. So again, one new H9N2 candidate vaccine viruses. If we switch now to what's been going on in swine, so you have another very, very active zoonotic interface with humans. In the swine populations, it's a more limited number of subtypes of influenza circulating, H1s and H3s, so similar to the viruses we see in humans, at least in subtype. The viruses themselves are a little different. There was a number of cases detected in the last 6 months across a number of countries. There was one fatal infection in Brazil. This individual had some underlying conditions, though, that probably led to the severity of the disease. Most of the time, like H9N2, these infections are mild, and again, most of them having exposure to swine. In terms of candidate vaccine viruses, most of the viruses that were detected in humans here were similar to candidate vaccine viruses we already had. The one area we were a little less confident on was these H3N2. So in the US, these human infections happen at the agricultural state fairs where people come along and it's a competition to show off your best animal. There's prizes for the winner. And often in these environments where lots of people come through these swine barns at these agricultural fairs, sometimes the virus does spill into humans. And that's what happened here. Although we didn't have the virus from that particular human case, there were some viruses detected in these agricultural fairs around where that human case occurred. They belong to a couple of different genetic lineages here. So these numbers here refer to lineages of these swine viruses, and doing the same thing here. So looking at these numbers in bold here and looking at how much smaller these numbers are than those numbers, you can see that really this current group of H3N2 viruses here were poorly recognized by any of the candidate vaccine viruses that we have, or anti-serum to those candidate vaccine viruses. So we recommended a new H3N2 like CVV, again, to represent this group of viruses circulating in swine that we know have the capacity at least to transmit from animals to humans. So I'm going to stop there. So I think, just to summarize, the zoonotic candidate vaccine virus development is an integral part of the VCM meetings. We're getting more and more information collected from a range of collaborative partners, both within GISRIS, the RLs, the H5 reference labs are key players here, as is OFLU, and additional partners, some academics, some other national partners that provide information and viruses to this as well. As discussed, the process is very similar to the one Nicola described for seasonal, just focused on a different set of viruses. The problem, of course, that we have in the animal realm is that there's such a huge diversity of viruses that are circulating in these animal populations. And that's where the challenge we have is we can't prepare against them all. So we've got to focus, do a more risk assessment approach to determining which CVVs we will develop. And as I said, 2 CVVs recommended past this past VCM. So a couple more to add to the list. Hopefully we won't need to use any of these, but just in case we do, they're there. And again, I think I've acknowledged to people through. So I will stop there and flick back to you, Wenjing.
Great, thank you, Richard, for the presentation. So we have about 15 minutes for Q&A. Before we start the Q&A, just to introduce the panelists. So the panelists, including the 2 speakers just spoke, and also my colleague, Dr. Aspen Hammond, who actually already typed quite some answers to some questions already, and me as well. So all of us jointly will be able to answer your questions. Look at the long list of questions in front of me. A group of the questions are related to the beyond component. So the questions cover like why or how we make this decision to remove the beyond. But just to clarify, for the upcoming Southern Hemisphere 2024 season, the quadrivalent vaccines, the vaccine composition are recommended, and to include actually the beyond there, while the efforts are being made to remove this component in the vaccines. The questions cover why or how confident we are the recommendation was made, and what we are going to do with this one additional component, if not beyond, what it could be, its implication to confidence, to trust on the vaccines, and how surveillance actually was conducted for beyond. Maybe Nicola, would you want to start answering these, and others would be able to complement.
Yeah, thanks, Wenqing. I did actually type some of the responses in the chat as well. So I think they're very important and very valuable questions that we have. I think if we start from the evidence-based side of things, some of the questions related to the bee lineage undetermined. And I think one of the things that's going to be very important going forward is that the surveillance within GISRIS remains strong, and that we encourage all contributors to the surveillance system to not only determine bee as a type, but also to lineage determine. And then it allows us the opportunity to follow up, were there to be any detections of bee Yamagata lineage, to understand the underlying epidemiology behind those detections. Because I certainly think it's true that we've been working very hard with the few numbers of detections that we have been reported to international databases to really understand what's been going on underneath. Coming to the question of if we could include an alternate component, it's a very attractive option for the future. And superficially, you could think that it would be very straightforward to slot in, say, a couple of H3 strains. However, the underlying science that would underpin a decision to alter the components within the influenza vaccine so that we could understand what the combinations, the best combinations might be. That evidence is not there yet. And so whilst it would be a very advantageous option for the future, we need much more research to underpin our understanding of adding different components. Clearly in the future, with perhaps new vaccine formulations, perhaps new vaccine platforms indeed, we would perhaps have much more flexibility in the way that we could respond to different proportions of different types or subtypes. But we're really not in that position at the moment. So we needed last week, certainly, to disentangle the two questions. One question about the bee Yamagata lack of circulation, and the other question around what we could do with a quadrivalent free slot, if you like. Moving forward, it is going to be critical that we, as we remove the bee Yamagata component, we remain vigilant for bee Yamagata viruses. And indeed, one of the things that we are really reaching out through the GISRIS network, particularly to our national influenza centres for, is to remind them of the importance of lineage determination and of really making sure that we understand the underlying epidemiology behind these detections. Wenqing, I think that's addressed some of the points. Shall I pass back to you and maybe you can pick up, you've got the long line list there, so that would be good.
Sure. So let me also add a little bit more also surrounding the bee yam component. Nicola said we need to differentiate the question about what additional component could be added vis-a-vis the circulation of bee yam. We also need to differentiate two questions. One is whether the virus is extinct vis-a-vis whether the virus should be in the vaccines. The committee considered that this component is no longer warrant was because the virus is no longer circulating in the population. And then another question asked how confident we are. So the influenza surveillance is conducted by this global network. And this network formally designated national influenza centers. There are more than 150. But beyond those, almost 170, 180 countries are contributing to the influenza virus surveillance globally. And this is year-round activity. So through this system, we can be very confidently to say that this virus, bee yam, is not circulating in the population. But this is different to have a special study that this virus is extinct from the world, from the earth. This is more towards the research studies. So this is one point I want to make. The second about the question about concerns about whether the removing of one component would destroy the confidence or having some negative impact. But I think it should be the opposite. Because why we're doing so is really we're looking very closely towards what should be in the vaccines that could be most appropriate for the vaccines for use in that particular season. The reality is that the virus is not circulating in that season. So I think this is in a simplest way is that there's no need for the virus to be in the vaccines. So I think the communication, we need to do it jointly with you, that instead of the confidence or confusion, but really need to increase the confidence on the vaccines. I would like to end by saying is that the current quadrivalent vaccines with this component is safe and effective. It's only because this virus is not circulating, we're working with national regulatory agencies to remove this component into the vaccines. So let me just stop here and we can, let me first ask if Richard and Aspen would want to add to this beyond related questions, because a lot related to beyond.
I don't think I've got anything to add apart from what yourself and Nick have just discussed, Wenjing.
Okay, so with this, we can move to the zoonotic questions. Actually, there are also quite a couple. Basically, it's $1 million question again. Richard, H5, H7, which one will stand out as the star or as the pandemic strain next time? What do you think?
Well, I hope the answer to that, Wenjing, is none of them. But we will see. So it's very, very difficult to put sort of a real numbers on the absolute risk of these viruses. So right now we consider the risk, the human risk of these viruses, at least from a pandemic perspective, to be low, but it is certainly not zero. And again, that's one of the reasons we do these exercises is for preparedness, just in case. I would also like to sort of make a pitch now for another GIS risk program that looks at this relative risk of these different viruses in animals, and is TIPRA. So that's a tool for influenza pandemic risk assessment, which is something we haven't talked about here, but it's another tool that GIS risk uses where experts score different viruses circulating in animal populations for their potential likelihood of emerging in humans, and if they do, what their impact will be. So another way of putting these viruses together and ranking which viruses, relative ranking of viruses, we should put resources into preparedness against. And when we do those exercises, often it is the H5s and H7s that appear near the top of that list. So in the context of where we're looking, we do look at the H5, probably in H7s very, very closely, but that there are also a number of other viruses out there that have zoonotic risk. We just unfortunately can't tell you right now what that absolute risk is. Is it 2%, 5%, 50% likely that they're going to be a pandemic virus? We just can't unfortunately tell you that. So that's why we've got to do what we do and do these preparedness activities just in case.
Thank you, Richard. Nicola, do you want to add anything about this question?
I think my crystal ball is about as foggy as Richard's in terms of what might emerge from the animal population. I'd say that the diversity is out there in the animal population, and we need to be ever vigilant. I think in some geographic areas, we can improve our surveillance in animal populations from a One Health standpoint, so we understand much more about the viruses that are circulating in wild and particularly domesticated animals, so that we can use them in a One Health way to use tools like Richard mentioned, the TIPRA, and to understand the risk at the human-animal interface. So I think that would be my thoughts on the zoonotic side, really to reach out to your national animal collaborators and to really work collectively together in the One Health space to understand what the viruses that are circulating in these animal populations. Thanks, Wenjing.
Thanks to you both. So as you just heard from our experts, that we at the moment, we really don't know what strain will be the next pandemic strain to cause influenza pandemic. but the signals being sending off now from the outbreaks, from the avian influenza spill over to mammals is really very alarming. So what we need to do is first strengthen surveillance so that if a virus emerged, if a pandemic virus emerged, we would be able to pick up very quickly. And second is research and development. Hopefully, actually, I think there was a question also here, the time needed for the vaccine development would be much shorter. So that means that the time needed between the emerge of the next pandemic strain and the availability of the first dose pandemic vaccine would be the time would be much shorter. So this is on the research and development that we need to pursue. We still have time, actually, maybe for one or two questions. Again, let's come back to the BEAM, because obviously people are very interested in the BEAM component. Nicola, maybe you could explain how the BEAM lineages are being determined in the surveillance.
So thanks, Wenqing. I think so what we have is we have a typing assay, and then we can obviously lineage determine. So there are reagents available that allow laboratories that are active in this area to be able to not only type the influenza that is circulating, but also to lineage determine. I think it's true, and I think actually Aspen might want to comment, because she's responding in the chat to the B lineage determination challenges. Aspen, do you want to respond? Because I know you've already responded about some of the reagents and that side of things from the technical aspect, from the assay point of view, because I know you've already been active in the chat. Passing it over to you, Aspen.
Yeah, thanks. I'll just summarize what I was putting in the chat, in that in some instances, in some labs and countries, they may not have the resources to do the further lineage determination. And if there's a need for sending samples for confirmation of lineage, there may not be enough sample left to do further characterization on. So we do encourage to have samples, subtyped and lineage determined, but sometimes that's not possible for the large number of samples that are detected, viruses that are detected. Over.
Yeah, and I think I'd just follow up with that thought that it's really useful to build a partnership between the national laboratories and the collaborating centres, because we can stand by. If there's a tiny bit of residual sample left, we are more than happy to assist in supporting the national laboratories in trying to aid the further characterization. And obviously, in some cases, we might be able to find sufficient material left for us to undertake sequencing as well. So really, I think it's very important that we use all the expertise within the GISRIS network in this particular B. Yamagata situation at the moment. And I'm speaking for my other collaborating centre directors, but we stand ready to assist in any way that we can. Thanks, Wenqing.
Thank you, Nicola. I would also would like to add about the issue about the risk mitigation measures. So please just don't think we just remove these in a way. We are working very closely with manufacturers, regulatory agencies with regards to risk mitigation. In case this flu B comes back and cause an outbreak, what we are going to respond. But of course, there's licensed vaccines available, although the license should need to be reviewed, need to be looked into, but also technologies available. It could be monovalent, like in 2009, then monovalent pandemic vaccines were being produced rapidly of those. But of course, the regulatory process need to be looked into, and this is joint preparedness with manufacturers, with regulatory agencies, and with this all together, whether we add a component or remove a component really should strengthen the confidence in the population towards influenza vaccines, which are being looked at very closely, very seriously by a group of scientists in the world. I think I have received the signals. I think I need to stop here. So it is already 5 minutes past. Just to say that the questions not answered online will provide written answers to you if we are not anonymous, because there's certain anonymous attendees. I don't know if we will be able to manage those, but we'll follow up certainly on this. With this, I would like to thank two speakers, Nicola and Richard, as well as my colleague Aspen in this webinar session, and I hand back to Supriya.
Thank you very much, Wenqing, and a huge thanks to Dr. Nicola Lewis and Dr. Richard Webby. We now come to the end of another very, very interesting EPI-WIN webinar, and we can see from the questions and from the chat remarks that people have been very engaged as well. Thanks particularly to participants. I see that from the chat that, we have people from all over the world, colleagues, for example, from Fiji. Thank you so much for staying up. It's midnight at your time, so we really appreciate your interest. Similarly from South America and other places where it's really early in the morning. So really appreciate that. I'd like to also thank the team that's gone behind this webinar. Dr. Aspen Hammond, who's been critical, from the concept onwards. Also Dr. Christopher Chadwick, and the EPI-WIN team here, Dr. Priya Umachandran, Dr. Agnesi Pastorino, both of whom are on break but have helped, particularly Priya, who's been instrumental in this particular webinar, Jiangfeng Liu, who's not here today, but she supported us with all the tech issues, Gabriela Santeso, and also Anton Perez. They've been managing all the back work, or including the tech work around this. My thanks to the interpreters from Transperfect. Thank you for joining us every time and having great translations, interpretations. We also would like to thank Interprefy for their AI-enabled translation. Of course, the biggest thanks to Wenqing, who has been leading this and conceptualizing this, and to Dr. Richard Webby and Dr. Nicola Lewis for sparing the time and for the fantastic feedback. All the webinar has been recorded. It will be on the website, along with in different languages as well. So you can share it further with your friends and your colleagues who couldn't make it. The presentations from the presenters will also be updated. And please complete our survey if you would like a certificate of attendance for this. And please tell us in the survey how you intend to use the information you learned here. That's very useful for us to make the webinars even more useful for you. And for those who have been waiting for certificates, my apologies. That's due to constraints in our team, both tech constraints and human resource constraints. As you know, both Priya and Agnesi, who worked in these webinars, are on break, but still working. We will get the certificates out to you as soon as we can. And if you would like to know more about future webinars, please join the link on the chat. We can put you on our mailing list. Thank you very much, and hope to see you next week for the new IPC guidelines on Ebola and Marburg. See you. Bye.